Okay, some practice problems. So this is Dalton's law practice problems. So a mixture of three gases, A, B, and C, is at a total pressure of 6.11 atm. The partial pressure of gas A is 1.68 atm. Gas B is 3.89 atm. And what is the partial pressure of gas C? So we basically have partial pressure of gas A plus partial pressure of gas B plus partial pressure of gas C equals the total. So all we have to do is plug in, because Dalton's law says that the three partial pressures add up to the total. So I have A is 1.68 plus B is 3.89 plus the partial pressure of gas C equals the total, which is 6.11. In the end, I'm going to subtract out everything, and I get 6.11 minus 1.68 minus 3.89, and so my answer is 0.54. So the pressure of ATM, the pressure of gas C equals 0.54 atms. So all three of these partial pressures add up to the total. Number 2, a gaseous mixture contains 1.5 moles of argon and 3.5 moles of carbon dioxide. The tank has a total pressure of 7.5 atms. What is the partial pressure of carbon dioxide? So 1.5 moles plus 3.5 moles is 5.0 moles total. So that's my total moles. So the mole fraction, X is equal to the mole fraction, that's what we call it. So X of carbon dioxide, right, is equal to 3.5 over 7.5. And what I can do is, so this is like total, right, which is equal to the moles of CO2 over the total moles. So if I multiply X of CO2 over the total moles times the total pressure, what I get is the pressure of the CO2. That's how this works. I take the mole fraction times the total pressure, and I get the pressure of the CO2. I can do the same thing with the pressure. I can say the pressure of the CO2 over the total pressure times the total moles is going to give me the moles of CO2. So the mole fraction or the pressure fraction times the total moles or the total pressure is going to give me the moles of the CO2 or the pressure of CO2. So I want the pressure of the CO2, so I'm going to use this formula. So I have 3.5 over 7.5 times the total pressure, times 5.0. Sorry, this number here should be 5.0 moles, total moles, 5.0, sorry. 3.5 over 5.0 times the total pressure, which is 7.5 atm. So I do that, I multiply that, 3.5 5.25. I go back up here and I see I get 2 digits, so that's 5.3. So in this tank, there's 5.3 ATMs of CO2. I know this because I took my moles of CO2, my moles of CO2 over my total moles times my total pressure, 7.5, which gives me my pressure of my CO2. Problem number 3. This is like the ones on your worksheet. A sample of water is collected over water at 22 degrees Celsius and 753 torr. What is the pressure of the volume of gas if the vapor pressure of H2O at 22 degrees is equal to 20 torr? So what I'm going to do is the total pressure is 753 degrees. This this is written wrong. I think this is a sample of vapor. So this problem actually says a sample of gas is collected over water. So when a sample of gas is collected over water, what's in the sample is gas vapor pressure plus gas vapor plus water vapor. And that equals the total amount of vapor, which means that the gas has its own pressure, so we have the pressure of the gas, plus the pressure of the water vapor, right? And that is equal to the total pressure. So here, our total pressure is equal to 753 torr. Then we're told that our water pressure is 20 torr, right? And what we want to know is what is the pressure of the dry gas. So that's what we want to find. So we subtract this off, and the pressure of the gas alone is equal to 733 torr. Now, I want to be clear about something. In your problems, they ask, what is the volume? And I apologize about that because they want you to convert this pressure into volume, which we have not done yet. So all I want is your pressure. That's all I want you to give me is your pressure. And I'm going to put that in the homework module, that you're just going to give me the pressure. So let's look at another one of these. All right. Okay, so oxygen gas is collected from an experiment over water at 27 degrees Celsius at a total pressure of 1 atm. The vapor pressure of the water at 27 degrees Celsius is 26 torr. What is the pressure of the dry gas? So we need to convert 26 torr to atm. That's the start, so that we can subtract it from the total pressure. Because remember, the pressure of the gas plus the pressure of the water is equal to the total pressure. So we need to subtract the water from the total pressure to get the pressure of the gas. So what we're going to do is we're going to take our 26.0 torr. We're going to convert this 760 torr to 1 atm. We're going to divide that out, which gives us 0.342 atm. Oh, 0.0342 atm. Okay, now I'm going to subtract that from the 1. So I'm going to move this over, and I'm going to say the pressure of the gas is equal to 1.00 atm, which is my total, minus, so this is P total, minus 0.0342 atm, which is my pressure of the water, which gives me the pressure of the gas is equal to 0.966 atm. But I only get 1 after the decimal point, right? See that? 1 after the decimal point. I mean, I guess, yeah, because it's a subtraction problem. You get 2 after the decimal point. So the pressure of the gas is equal to 0.97 atm. That's it. 0.97. Okay, so subtraction here, 0.97, I guess you could say. All right, 0.97. Okay, so that's it. There's other videos up for grams, a couple problems with grams, laws of infusion, and a couple problem with conversions.